Welcome to our second class. Today we'll be talking about factorial, permutation and combination. First, talk of factorial. Factorial. Let n be a positive integer. Positive integer means that positive whole number. Then if you have n factorial, it simply means n into n minus 1, n minus 2, n minus 3, like that up to 3, 2, 1. What this thing means is that when we have anything factorial, it starts from that thing which is n, followed by this bracket means times, followed by n minus 1, followed by n minus 2, like that. It will be reducing. For instance, 5 factorial means starting from 5 to 4, 3, 2, 1, and that will give me 120. 4 factorial means 4 times 3 times 2 times 1, that will be giving me 24. And finally here we have 1 factorial means 1. 0 factorial is also 1. So the beauty about this thing is that when you are given something like this 7 factorial, I can write it as 7 times 6 times 5. If I decide to stop here, I'll put factorial. You don't need to get it or put it up to 1. You can stop anywhere you like. So that means I can write 8 factorial. I can write it as 8 times 7. If I want to stop at 6, then I'll put factorial. So far it is not the end. The end should be 1. But if it is not the end, it can stop here. Now let's take an example on this. Take this as an example. Evaluate the following. 8 factorial divided by 5 factorial. Since 8 is more than 5, I know that if I am reducing 8, I'm going to meet 5. So I will reduce the largest one, which is 8. So 8 factorial will now become, as usual, 8 times 7 times 6 times. So I can see that I stop at 5, I put factorial. Why did I stop at 5? Because I know that there is 5 factorial here. I don't need to write it up to 1. And if you decide to write it up to 1, there's nothing. There's no problem. You just need to cancel the common one. From this list now, I will now see that 5 factorial cancels 5 factorial. Finally, what we have left will be 8 times 7 times 6. And that should give me 336. So if you have another one, let's say we have 6 factorial over 2 factorial. 6 factorial will give me 6 times 4 times 3 times. I can decide to stop at 2 factorial. Then I will write 2 factorial again. Because there is 2 factorial here. From that place, 2 factorial cancel 2 factorial. What we have left will be, there is 5 here. 6 times 5 times 4 times 3. So what we have left will now be 6 times 5 times 4 times 3. And that will give me 6 times 5 is 30. 30 times 12, that is 360. What I want you to gain here is that if you have anything factorial, anything at all, it starts from the thing, bracket, the thing minus 1, bracket, the thing minus 2, like that. For instance, if I now have, let's say I now have Martin's factorial. So it will start from what? Martin's. It will be Martin's into bracket, Martin's minus 1, Martin's minus 2, like that. It will be going like that until it gets to 3, 2, 1. 3, 2, 1 is the last numbers. So this is what I want you to gain there. And also what I want you to gain is that if you have 7 factorial, you can decide to write it up to 1. That is 7 times 6 times 5 times 4 up to 1. Or you can decide to stop here. But anywhere you want to stop, which is not 1, you have to put factorial there to show that the number still continues. So let's go to some equations involving this factorial. Here we want to find the value of n. I have n factorial is equal to 12 into n minus 2 factorial. The first thing is I have factorial in 2 places. I'll first think of which one is the highest out of these 2. So n factorial is more than n minus 2 factorial. So I have to reduce this one. I will now use the formula, which we have said that anything factorial is anything n into n minus 1 into n minus 2. But I have to stop here. because in the other side I have n minus 2 factorial. But since it's not 1, I have to put factorial here. That is, all these are meant for n factorial. And the other side is still our 12 into n minus 2 factorial. From this place, the common ones will be cancelled. You observe that n minus 2 factorial is common to this. It will be cancelled. So what we are going to have left to be n into n minus 1 equal to 12. This will lead to quadratic equation. But in order not to stress ourselves in quadratic equation, we have a short method to use. How do I solve this quadratic equation easily? What is here means that two numbers are multiplied together to give me 12. I will just look for the two numbers that if you multiply them, it will give you 12. So those numbers can be 2 and 6, 12 and 1, 4 and 3. But the one to use will be the one that follow each other consecutively. So what we are going to use now is 4 and 3. 4 times 3 will give me 12. That is the one we use. Anyone that follow each other consecutively. So from this place, I can, if you have written it in this format, then compare. Just take the first one. The first one, just say n, then write equal to what is here, which is 4. That will be the answer. Or if it is the second one you want to take, the second one here is m minus 1, and the second one here is 3. You must write higher number first before the smaller number. From this place, if you make n the same formula, n will be 3 plus 1, which is 4. Now, let's take another example for better understanding. Second one, n plus 3 factorial is equal to 24n factorial. We observe that 24 n plus 3 factorial is more than n factorial, so we have to reduce this one. And we have said that anything factorial, let's take this as Martins. N plus 3 factorial, let's take it as Martins factorial. It will now become Martins into Martins minus 1 into Martins minus 2, Martins minus 3. I can stop here. If I stop here, I must put factorial. Since it's not the last one, I have to put factorial. Is equal to the second side, which is 24n. That does not change. If I simplify this further, this is n plus 3. n plus 3 minus 1 gives me n plus 2. n plus 3 minus 2 gives me n plus 1. And 3 minus 3 is 0. It remains ordinary n. This is the n factorial. From this way, you see that n is common. From that place, n will be cancelled, and we are going to have this. n plus 3, n is cancelled. Now, we need to solve this cubic equation. In order to solve it, we have to use a shortcut. This thing simply means that 3 numbers are multiplied together to give me 24. But the 3 numbers must follow each other consecutively. So we look for 3 numbers that can give me 24. So the numbers that follow each other that will give me 24 will be 4, 3, and 2. 4 times 3 times 2 will give me 24. So in that case, we cannot have this. n plus 3, n plus 2, n plus 1 is equal to, our 24 will now become 4, 3, 2. It has to be highest to lowest. So if you have written it like this, just like what we did before, just pick the first one alone. The first one is n plus 3. Just equate it to 4. n plus 3 is equal to 4. So n plus 3 is equal to 4 will become, if you make n is a formula, n will be equal to 4 minus 3, which is 1. In that case, our n is equal to 1. Also, if it is the second one you want to pick, just say that n plus 2 is equal to 3. You will see that n is still be equal to 1. So that solves our question. Now, let's quickly move to permutation. Now, consider this ABC here. You know, I can rewrite it as ACB. I can rewrite it as BAC, BCA. I can write it as CAB, CBA. So I have 6 arrangements here. Now, all these arrangements here, this is what we call permutation. As I'm rearranging this thing in a certain order, then we call it permutation. Is permutation definition. A permutation is the arrangement of objects in which order is considered. So if they say that permutation simply means arrangement. We say it's the arrangement of object for which order is considered. Mathematically, we represent permutation like this. N, this time means n permutation R. We said the permutation of R from n is given as n permutation R is equal to n factorial over n minus R factorial. Here we assume that n is greater than R. That is, whatever that is here must be greater than whatever that is here. So we take example. I have example here, 5 permutation 3. Here our n is 5, our R is 3. So it will now be 5 factorial over 5 minus 3 factorial. And that will be 5 factorial over 5 minus 3 is 2. So this one now leads to what we did before. So we need to reduce 5 factorial. That will be 5, 4, 3. Then we stop at 2 because there's 2 factorial here. So it cancels each other. What we have left is 5 times 4 times 3. And that gives me 60. Also, 7 permutation 4 is 7 factorial over 7 minus 4 factorial equal to 7 factorial over 7 minus 4 is 3. And reducing it, it will give me 7.6.5.4 over dot 3. We stop at 3 factorial because of this one. So it cancels each other. We are going to have 7 times 6 times 4 left, and that will give me 840. That is that about permutation of two numbers. Now, a shortcut to this permutation is this. When we have 5 permutation 3, for instance, shortcut is this. 5 permutation 3 simply means I should reduce 5 and I'll stop at the third number. This thing, I'll call it third. So that it will now become 5, 4, and 3. Because this is the first number, second number, and the third number. So in that case, our 5 permutation 4 will now be 5 times 4. And 5 permutation 3 will now be 5 times 4 times 3. Also, 7 permutation 4. That one simply means I should reduce 7 and stop at the fourth number. And that will be 7 times 6 times 5 times 4. This is the fourth number. 7 times 6 times 5 times 4. So that will be 7 permutation 4. So in that case, I can say that 9 permutation 3 is equal to 9 times 8 times 7. Because the third number, this is the first, second, third. In fact, I can say that 10 permutation 2 is equal to 10 times 9. Because this is the second number. 10 permutation 2, 10 times 9. And so on. We can simplify it like that. It will be easier for us than using the formula. Now, let's consider some factors again. If n factorial means, if you want to reduce n factorial, which is a letter, it is the letter into the letter minus 1, whatever, minus 2, minus 3, and so on. Now, that means if I have n permutation 2, I'm going to reduce n, and I'll stop at the second one. That is, this is the first one, this is the second one. That means n permutation 2 will have been n into n minus 1. That is n permutation 3. I'll reduce n and I'll stop at the third number. So it's to start from n, followed by n minus 1, followed by n minus 2. This is the third number. So that means if I have something of this nature, n permutation n plus 2 permutation 3, it will start from whatever that is there. That will be n plus 2 reduced to the second one, n plus 2 minus 1, n plus 2 minus. So this is the third number. First, second, third. And that will give me n plus 2, n plus 1, and ordinary n. So this is n permutation 3. With this idea, we can solve some questions there. I want to find n here. N permutation 3 is equal to 120. n permutation 3 simply means I should reduce n and stop at the third number. That will be n into n minus 1, n minus 2. This is the first, second, third. So this 3 will become n permutation 3 equal to 120. So I need to solve for n here. Just use the formula that I explained earlier. Look for 3 numbers that follow each other consecutively. That will give you 120. The numbers will be 6 times 5 times 4. So that will be 6 times 5 times 4 will give me 120. So I will write from the highest to the lowest. So just pick the first number. The first number here is n. The first number is 6. Finally, our answer is n is equal to 6. That's the answer. There's no any more working. But if you want to be sure, pick the second number. The second number is n minus 1. Equate it to the second number here, which is 5. That's why we have n minus 1 is equal to 5. If you see that if you make n is the same formula, n will be equal to 5 plus 1, and that will be 6. In each case, n is equal to 6. Let's consider another example. Now, we want to find n here. N permutation 4 is equal to 30 n permutation 2. So solution, n permutation 4 simply means I should reduce n and I stop at the fourth number. So that will be n into n minus 1, n minus 2, n minus 3. So this is first, second, third, fourth is equal to, this is our 30. N permutation 2 means I should reduce n and stop at the second number. That will be n into n minus 1. You will now observe that n is common, n minus 1 is common. They will be cancelled out, and we are going to have n minus 2, n minus 3 is equal to 30 left. From this, but as usual, how do we solve this? We look for 2 numbers that follow each other, because these things are 2 numbers. That will be 6 and 5. They will follow each other. The highest one first. Just take the first one to the first one. Just equate it, so that we are going to have n minus 2 equal to 6. That is, this one is equal to this. Therefore, if you make n the same formula, n will be equal to 6 plus 2, which is 8. So n is equal to 8 is the solution to this. So if you consider another example, let's consider another example. N plus 1 permutation 3 equal to 720. That will give me, that is, we reduce n plus 1 up to the third number. If I are going to reduce n plus 1 to the third number, I will first start with n plus 1. It will be reduced by 1. This one will leave, it will remain n. And this n will be reduced by 1 again, that is minus 1. So we have it in 3 places. This is permutation 3 is equal to 720. But how did we even get this normally? If you consider this thing, n plus 1 factorial. You know, it starts from n plus 1, followed by n plus 1 minus 1. That is, anything factorial will be the thing, followed by the thing minus 1, the thing minus 2. And that will now give me n plus 1 minus 1 plus 1 minus 1 is gone. We have n left. And here, 1 minus 2 is minus 1. So we have n minus 1. That is how we got this. Now we are now looking for 3 numbers that will give us 720. And those numbers will be 10, 9, and 8. They will give us 720. So that will give me 10, 9, and 8. Just pick the first number. The first number is n plus 1 equal to the first number here too is 10. So we say that n plus 1 is equal to 10. Then you need to make n the subject of formula. N will now be equal to 10 minus 1, which is equal to 9. And that completes the solution. So we move to arrangement of distinct elements. Arrangement of distinct elements. Now, in order to explain this, we have to explain through examples. Now, look at example 1. In how many ways can the letters of the following words be arranged? The first thing is, we observe that there is no any common alphabet here. I, K, E, J, A. We want to arrange it. How do we do this? We just need to count the number of letters there. Then we put factorial. So if I count this, I have 5 letters here. Then the number of arrangement will now become 5 factorial. And we have known 5 factorial to be 5 times 4 times 3 times 2 times 1. and that will be 120. So we say 120 ways. Also, if you count the letters of the word Daniel, there's no repeated letter here, and we have 6 letters there when we count it. So our total arrangement in Daniel will just be 6 factorial, and that will become 6 times 5 times 4 times 3 times 2 times 1, and that will give me 720 ways. So this will give me 720 ways. So that means if I'm to arrange all this, I'm going to have 120 ways. If I'm to rearrange this Daniel, I'm going to have 720 ways. But we use this when the elements are distinct, that is, when they are not repeated, when they are different from each other. Now, let's now consider a case whereby the elements are repeated. Now, arrangement of repeated elements. So, in how many ways can the letters of the following words be arranged? Now, Abuja, you observe here that A is occurred. A occurred twice. So A is repeated. In that case, the first thing, how do you do this? Count the letters as usual. I have 5 letters there, so as usual, I'll put 5 factorial. Then I'll count the numbers of letters that are repeated. A is repeated, but twice, just twice. So I'll say over 2 factorial. So you are getting it like that. That is over 2 factorial. So that will be 5 factorial over 2 factorial. 5 factorial should give me 120. 2 factorial should give me 2. Our answer is 60. So in 60 ways, I can arrange Abuja. Also, I want to arrange the word Miriam. Miriam will be 1, 2, 3, 4, 5, 6. So I have 6. So I'll first put 6 factorial there. But note, M occurred twice. A occurred twice. You have to do it separately. Since M occurred twice, we are going to have 2 factorial. That is for the M. Also, A occurred twice. I'm going to say another 2 factorial. That is for our A. Anyone that is occurred twice like that. So I cannot simplify this. 6 factorial will now give me 6 times 5 times 4 times up to 1. And that will give me 720. As usual, 2 factorial is 2. Another 2 factorial is 2. This is 2 times 2. So we will now divide this. When we divide this, we should have 180 ways. So it means in 180 ways I can arrange Miriam. So you can try this on your own. You can try this. Try this. Accesses, Martins, economics, and universities. You can practice this and try it on your own to find the number of arrangements we can have in these letters. Also, let's consider another example. In how many ways can 4 people be seated on 6 seats? So that means we want to arrange 4 people on 6 seats, 6 available seats. So in that case, it's arrangement. So since it's arrangement, we say it's permutation. So our answer will be 6 permutation 4. 6 permutation 4. So 6 permutation 4 will be 6. 6 in 4 places. You reduce 6 and stop at the 4th number. That is 6 times 5 times 4 times. This is 4th number. And that will give me 360 ways. Now, questions don't always come straightforward like this. Sometimes we have condition attached to it. So it will lead us to conditional arrangement. So conditional arrangement. So let's consider this example. In how many ways can Abuja be arranged such that A, there's no restriction? There's no restriction means that there's no any condition attached to it. B, ABU, this ABU must be together. C, ABU must not be together. Now, for the first one, we want to arrange the word Abuja. It will just be normal. I'll count the letters there, which is 5 factorial. A occurred twice. That is 2 factorial. And that will give me 120. 5 factorial is 120. 2 factorial is 2. And that will give me 60 ways. Now ABU must be together. If ABU must be together, this is how we normally do it. We write ABU and we bracket it like this so that they must be together. Now this ABU, they'll become 1. We have 3 letters there already, but you make it to become 1. So the letters we now have will be 1. If you are counting it, it should now be 1. The whole of this 1, 2, 3, and nothing is repeated. So in that case, if I have counted 3, then I'll put factorial. Now for this case, you say times the one that you bracketed before. So you come back to it. This bracket one, we come back to it. When we come back to it, we count the letters there too. 1, 2, 3. Different letters. So I'll multiply by that 1 inside too. So that my answer will become 3 factorial is 6. Another 3 factorial is 6. And that will give me 36. 6 times 6, 36 ways. Now the last one, ABU must not be together. For ABU must not be together, you only need to subtract this no restriction minus they must be together. It will give you they must not be together. That is how it is being done. So that my answer will now become 24 ways. 60 minus 36 will give me 24 ways. Let's give another example for better understanding. Before we consider that example, look at this one. ABU must not be together. It simply means they must this no restriction minus they must be together must give us they must not be together. So in 24 ways we can have that. That simply means that question can just come to this last one directly, that ABU must not be together. And to find it, I have to go through these 3 steps. I have to first find no restriction. I must find ABU must be together before I find ABU must not be together. For instance, look at this example. In how many ways can the word access be arranged such that ACC must not be together? This is a direct question. This is an indirect question, sorry. I have to follow the 3 steps. That is, I have to follow no restriction, I have to follow ACC must be together, and I have to follow ACC must not be together. So let's first consider no restriction. So ACC, the no restriction, sorry. Access will become 6 factorial. I will count this. I will note that C occurred twice, is 2 factorial. S occurred twice, is 2. And if you simplify it, you are going to have 180 ways. Now, ACC must be together is our second step. I said that ACC must be together. Just put it in bracket. They will become 1 alphabet. So in this case, I will not count this. But note, you have to watch out for any repeated letter. But not in this case now, because this is 1 letter. This has become 1 letter. 1. Let's now count it. 1, 2, 3, 4. I have 4 letters. So our answer will now be 4 factorial. But out of these 4 letters, you observe that S occurred twice. So I will say over 2 factorial. Always, I will say times this ACC, the one inside, I will count it too. But if I count it, don't forget that C occurred twice. Our answer is 1, 2, 3. That will be 3 factorial. Because C occurred twice, I will say over 2 factorial. And simplifying it, our answer will become 24 over 2 times 3 factorial is 6 over 2. 24 over 2 is 12. This is 3. 12 times 3 is 36. So it cannot lead us to our question. ACC must not be together will now be 180 minus 36. That will be 144 ways. Circular arrangement or ring arrangement. So we say the arrangement in ring or circle or a circular form is given as n minus 1 factorial. That means if I'm to arrange 10 people in a circular form or in a round table, I can say round table or circular form, our answer will just be 9 factorial. That is 10 minus 1 factorial. So we have that. So let's consider this important as an example again. Now another example, if the word comics is arranged, how many will not start with X? To get this, I have to know how many will start with S. In order to know this, I have to know how many will start with S. If I have known how many will start with S, then with the help of the former idea, we can get it. First, find no restriction. So how do we arrange comics? I'll count it 6 factorial, C occur twice over 2 factorial. That gives me 360. Also, word that will start with S, how do we find it? I will place S here. Then I will arrange COMIC. I will arrange it. So all this, I will just arrange this. So our answer will be equal to, so counting the one in bracket, 1, 2, 3, 4, 5. So I have 5 factorial. And 5 factorial will give me 120. So that means the number of words that will start with S will be 120. I don't need to, this S will be fixed. Then I will just arrange this. So from that place, I cannot come to the one that will, I cannot come to my question. Numbers of letters that will not start, the words that will not start with S. That will just be 30 minus 120. So words that will not start with S will now be 360 minus 120. And that will be 240 ways. Those are the words that will not start with X. So we will now move to combination.